Okay, so we know a little bit now about moving averages. Let's put it into practice on this question. Okay, so we've got this geography department keeping records of rainfall, and we've got spring, summer, autumn, winter each year, and all values of rainfall are given to the nearest millimetre. So we've got a 355 and we've got to work out where that came from. Well, that's right in the middle of 2009. Okay, this goes together with part B. How many points are used in the moving averages? Well, not only does it make sense to put 4 quarters of a year together, so we expect this to be based on these 4 numbers, we can see it's at the exact centre of those 4 numbers. Okay, so therefore the 355 must have come from 275 plus 383 plus, sorry, that's 383, okay, plus 447 plus 315 divided by 4. Do that on your calculator and you do get 355. Don't know if there's some rounding going on, but I know that's the right answer. How many points are used in the moving averages? They're 4-point moving averages we've seen, so it is just 4. Okay. Complete the rest of the moving averages and plot the final one on the graph. So this was really just here to give you a reminder, something you could check to make sure that you're set up to do the moving averages. When we work out moving averages, then it makes a lot of sense to just edit each one before we move on to the next. I'll show you what I mean on a calculator. First thing is get into the habit of using this fraction button so that you can enter fractions exactly as you would write them or they would be printed. So I'll do that first calculation. So there it is, exactly as I've got it written here. And when I press equals, then I get 355 as we know. Now the next calculation is going to be the same thing, except instead of 315, it's going to end with the next one, plus 222. But in compensation for that, at the other end, I've got to get rid of this 275. So I can just delete that and the plus sign after it. And this will give me my next moving average. 13767 over 4 is 341.75. I'm going to enter that. Does it say... No, it doesn't say any particular level of accuracy. Now, when I come to plot it on the graph, however, 342, 3 significant figures, is the best I'm going to be able to do. So I think rounding to 3 significant figures is entirely appropriate. Okay, so you just keep going and filling in the remaining moving averages. Okay, so I'm not going to do that with you. All right, I'll show you the answers, but I suggest if you're filling this in a blank booklet that you go away and work out the remaining values. So pause the video, do that. Okay, so I've filled them all in here. Then we've got to add the final moving average to the graph below. So that's the 251. So I've got to find where it goes. So this was formed by looking at winter, spring, summer, autumn from the end of 2010. So winter, spring, summer, autumn. The midpoint of that, sorry, down here. Okay, so winter, spring, summer, autumn. The midpoint is there, so I need to go to this value here, and I need to go up to here and find 251. So finding on this scale, I think it's this line I need to go up from, and I need to go across from 250 and find 251, which is indistinguishable from 250. So my final point goes there. Okay, which you can probably guess just by following the pattern. Okay, it does actually continue the pattern. So we can then, part D down here says we need to draw the trend line. Okay, and we always do this with a ruler. If they ask you to draw a trend, they'll only ask you to do that if it's linear. So on this particular occasion, we need to find a line of best fit by eye, but on this particular one, the points are such a lovely straight line that I can pretty much find a line that will go through all of these points. Okay, and notice I've drawn it nice and long. You can draw the trend line as long as you like in both directions. Okay, so that's down to part D, but let's keep going. So part E, we've got to calculate the seasonal effect for the winter quarter. Okay, now what we mean by seasonal effect is explained up here, but I'm going to explain it using the graph, using this example. So for the winter quarter, okay, we can now see that, as you might expect, winter is slightly, actually you might expect it to be a lot wetter than average, but if we look at the winter values here, if I go up from winter, okay, through the winter point, okay, draw a vertical line through there, okay, I can see that the actual rainfall, the plotted rainfall there for winter, is below the trend line, okay, which is telling me, all right, maybe it's not what you expect at all, it's telling us actually that winter is slightly drier than the overall trend, okay, and if I go through this one here, all right, that one is also slightly below the trend line. I've only actually got 2 winters to go with, so I've got this one here, I've got this one here, and I can see actually the distance between what the actual rainfall and the rainfall predicted from the trend line, what we call the residual, is about the same in both cases. And because we're below the trend line, the actual is less than the predicted, we're going to have negative residuals. These are the same kind of residuals as we had in S1. So the seasonal effect for the winter, I have to look at both of these residuals I've got, okay, so I have to do a little bit. You can either read off some numbers and subtract them, okay, because I have got the actual raw data. I know that this value here for winter 2009 is 315, so I can use that and I can try and estimate this value here. It looks like it's about 335 to me. So for the first one, we get 335, okay, but that's the estimated one. The actual was 315, okay, minus 335, because I'm doing the actual minus the predicted, okay. So just go back to the graph, 315, that value there is 315, that's the actual, but the predicted one here, this is the one that is the 335, okay. And the next bit of winter data I've got is down here, okay. The actual I can read across, it's about 250, I can look it up in the table, it's 255, okay. And if I read across this value here, the predicted one, I come across here, then horizontally, coming across like this, okay, it's almost exactly halfway between 250 and 300, so that looks like it's 275. So again, I do the actual one, so the plotted point of 255, okay, 255, and the prediction was 270, so 275. So I get 20 for this and I get 20 for that. Now you don't always get exactly the same answer each time. So the way we actually get the seasonal effect, the winter effect, is we work out the mean of these residuals. The actual values minus the predicted values read from the trend line. So that's 20 plus 20 divided by 2 is not surprisingly 20 again. Okay. Sorry, these are minus 20. Sorry, really important point there. Minus 20. This is minus 20 plus minus 20. So the effect is minus 20. It matters the negative sign because the minus is telling us that the actual one is less than the predicted one. So the winter effect is minus 20. Okay, now we're going to do a forecast. Now a forecast has got 2 bits. Firstly, there's a trend line prediction. Okay, and then we have to allow for the seasonal effect. So if I come back to my graph, I want winter 2011. So that's set up for us on the x-axis. Winter 2011 is here. So if I go up from winter 2011, so drawing on the graph is recommended. So up from winter 2011, up to the trend line, make sure it's nice and vertical. Okay, then come across from the trend line, making sure it's nice and horizontal. Okay. And that seems to be, I've done that right, that seems to be 210. Okay, so 210 is the trend prediction. All right, but I need to then minus 20 for the winter effect. Okay, which gives me a prediction, a forecast of 190 millimeters. Okay, and now in part G, we've got to give reasons why using that same method to forecast the rainfall for 2020 winter, okay, would be inappropriate. Well, a number of things you could say here. The first one is the same point we had in S1 about extrapolation. Now, you could say that what we did here is extrapolation. We're going beyond the given set of data, and it's undeniably true. But we're not going very far beyond. So we could already criticize this and saying that we're assuming that the current patterns will continue. But assuming they'll continue for a little while probably isn't too bad a thing to do. Okay, but we'll come to that in a second maybe. All right. But going from 2009, 2010, 2011, all the way to 2020 is ridiculous, okay? So we could just say it's going too far into the future, okay? We could say that the line going like this, I can see that it's going down and down and down. This line is 0. So if I don't have to go very far this way before I'd actually go past 0. Now what's on the vertical axis? This is rainfall. So if I extrapolate that line to anywhere near 2020, it's going to predict negative rainfall, so that's impossible. Okay. And the other thing is this line only covers it's only from data based on just 2.5 years. Now that is no kind of way to get any evidence that the trend we're looking at here is necessarily a long-term trend. So you can give a number of different reasons here. Okay, what I'll do is I'll show you some of the reasons that when this was an exam question would have been allowed. So you could say we're extrapolating too far, we're going too far into the future. You could say that the pattern that we've noticed from this data is likely to change. You could say that the point about the fact that the rainfall looks like it would be predicted to be negative. You can even talk about other things like climate change is going to have an effect. And you can say that the data we've got is over a very short time. So those are some of the things that would be allowed. Okay, and to finish off, we've now got some actual data. So the actual winter rainfall was 259. Okay, what did we predict it as? We predicted it as 190. Okay, so I've got to comment on the accuracy of that. Well, this is really easy. Okay, our prediction, the forecast, was too low. Forecast was too low. All right, okay, but we've also got to comment on the trend, okay, and that's where we need to look at the next 3 moving averages, 252, 254, 258. Now, it doesn't say we have to plot them on the graph, so maybe we shouldn't do this too boldly, but let's think about where they would be. So 252, 254, 258. So 250 is over here. So my next moving averages would be plotted here and here and here, and they're all around about 250. So they'd be there, and they'd be there, and they'd be there. And in fact, we can see from the numbers that, in fact, if anything, they're going very slightly upwards. All right. So we've got this trend that we drew in, but then the next 3 moving averages would, if you like, go straight across. So I wouldn't make too much of the fact that they seem to be increasing because it's only very fractional, but we can certainly say that the downward trend does not seem to continue. So downward trend has stopped, and that's all we need to do. That's a complete exam style question. That's the kind of thing that you need to do on moving averages.